All right. Well, here I am going to solve this exercise. I think where it stands, this is currently number 1 in 6 point. Let me see what this is in my notes for my students. This is 6.4 trig integrals. Okay. So let's get back here. All right. So yeah, we want to set up our triangle here. We want to identify our A value. Our A value looks to be 1, so that if we square 1 minus x squared and x, let's see what would happen if we square those. We would get 1 minus x squared plus x squared. And I think you can see that this ratio works out. Okay, so yeah, we identify our A as 1. Okay. Likewise, we're going to go ahead and set our x equal to 1 sine theta, so that our dx is 1 cosine theta d theta. Just something we always do in this particular type here. Okay, so let's go ahead and get in here, start substituting things. What we have is 1 minus, now x is sine, so that's sine theta squared. We have dx is cosine theta d theta. And we do need to substitute the bounds. These are currently x bounds, x from -1 to 1. If you think that x is -1, plug it in here, you get -1 equals sine theta. Now you're trying to pick an angle kind of in between pi over 2 and -pi over 2, where the theta would give you -1, sine of theta would give you -1. That is not currently, we usually try to pick them in between these bounds. That is possible here. Yeah, sorry, I misspoke. -pi over 2. So the sine of -pi over 2 would indeed be -1. Okay. Likewise, x equals 1. You put that in. Let's see, where are we putting that? Right here. That's going to lead to 1. So what angle would it be where sine of theta is equal to 1? That's pi over 2. Okay. All right, so proceeding here, we've got these bounds. We're going to go ahead and substitute the cosine squared. That's the Pythagorean identity. This is really going to just be cosine squared theta. So we're going to look to apply the power reduction formula, which is that cosine squared is cosine 2 theta plus 1, all multiplied by 1/2. Okay, what that's going to do for us is that's going to allow us to finish this integration. Okay, so sorry about this camera angle. I got it a little bit closer there. All right, so we're going to integrate this first piece, and then we're going to integrate this second piece here. So the first piece is going to go up to be sine 2 theta, and that extra 2 is going to come underneath. The 1/2 is going to get a theta, and we're going to need to plug in these particular bounds. Okay. So we need to plug in pi over 2. So the 2's are going to cancel. 2 times pi over 2 is going to be pi. Minus, plug in the lower bound. Again, it's going to be negative pi. I almost missed that negative there. Minus here. Okay, let's double check that I didn't make a mistake there. Minus 1/4 sine 2 times negative pi over 2 is negative pi. Okay. Now, sine of pi is 0 and sine of negative pi is 0. So what we have is 1/2 pi over 2 plus, okay, we can go ahead and call it even with pi over 4, so that this is all looking like pi over 2. And that concludes that one.